I'm basically going to show you how easy it is to make applications scale using a data grid. And for the sake of argument, I'm going to use a web application today. Keep in mind, I'm not a web application developer. I'm not a web app guy, but I'm still going to do it just to have a bit of fun, right? I'm specifically going to use CDI. Are people here aware of CDI? Do people here know what CDI is? Yeah, lots of nods. Good, good. I'll talk about it a little bit anyway as we go on. And primarily this talk is about, like I said, building a web app, making it scale using a data grid. Now, we all know that data grids are good to help things scale out, but you need to use specific APIs, you need to know what you're doing. It's not that easy for your average web developer. What I'm trying to show is that it can actually be kind of easy in certain cases, or in quite a few cases anyway. So it's not specifically a data grid talk. I'm not going to talk too much about data grids. I'm going to introduce data grids a little bit. I'm going to talk about why they're good for scalability in a very, very high level. But if you do have any questions about data grids in depth as well, we can always field that at the end, okay? So just to get things going. Is that on as well? No. A little bit about me. My name is Manik Surtani. I am an architect at JBoss, Red Hat's middleware division. I'm on the expert group of JSR 107 and JSR 347. Who's heard of these two JSRs? Any hands? Who actually cares about them? Who's interested in them? Are they interesting, useful? Kind of boring? No one cares about the JCP anyway? No? No, they're very, very good things, trust me. And if you're not involved, you should get involved. I'll leave some URLs at the end where you can learn more about them. I'm also the founder of Infinispan, which is an open source data grid. Who's heard of Infinispan here? Any hands? Okay. I mean, for those of you who haven't, I will talk a little bit about it as well to introduce you guys to it. There's the details of my blog and Twitter feed if anyone's interested. And we've also got a book on Infinispan if anyone is interested. It's down at the Red Hat booth. Come down there. If you're lucky, we might give you a copy. All right. So CDI, getting started. A few hands went up that you are familiar with CDI. You know what CDI is. For those of you who don't know what it is a very standards-based programming model. You might say it's a standardized form of Spring. That's the easiest way I've ever been able to describe it. It is an injection framework. It wires up applications together. It makes things very testable, clean, and easy to build applications. Now, the good thing with CDI is it is a part of Java EE 6, which means that everything you need to build a CDI application already exists in a Java EE 6 server. You don't need any additional libraries, any additional dependencies. You get essentially a DI framework that is type safe, standardized, portable, etc. Lots of good things, right? In some ways, it's the preferred way of building any Java EE app today. That logo is a logo for Weld. Weld is the reference implementation of CDI. Right? The next thing I'm going to do when I build this web app here is I'm going to use something called Array. Now, a lot of you may not have heard of Array. Maybe a few of you have. Yeah, it's a funny name, I know. Any hands who's heard of Array? Okay, a few people. See, not that many. Array is a rich client framework. It's essentially EE6 in your browser. Array is built on top of GWT, so you end up writing Java code, right, object-oriented Java code, which is then compiled into JavaScript and runs in your browser. The reason why I'm using Array in this particular demo, a couple of reasons. One is it is compatible with CDI, so you have all the CDI annotations on top of Array, which makes it very easy, very clean to use. The second thing is Array is a JavaScript, effectively a JavaScript framework. It does generate JavaScript, like I said. So I'm going to use it to generate a lot of data, a lot of interaction between your browser and your backend, right? So without using, I mean, I could use long polling, I could use WebSockets, I could use 200 different things out there, but it's a pain in the ass to sit and write all that. Array makes it all very easy to do, right? The next thing I want to talk about, Infinispan, I mentioned very briefly again. It's a distributed in-memory data grid. It is open source. It's been around for a long time now, for a few years. Pretty active, very active community actually, of everything from developers, end users, OEMs, people who are extending it, embedding it, doing all sorts of cool things with it, right? So pretty popular project out there. It is often used as a NoSQL key value store, as a database replacement. It's also used in front of a regular database as a performance enhancing mechanism, as a cache, either a standalone cache or a distributed cache, and things like that. So how are we doing so far? I've introduced 3 projects here. All happy with that? I mean, I will go into more detail of any one of them if you want me to later on, yeah? But for now, that's a very quick intro to the 3 projects. I'm going to change gears. I'm going to talk about scalability. Who's ever had that problem before? I'm not talking about being tied to a cart or anything here, but, you know. You have? Okay. I feel sorry for you, man. No, essentially, right, you try and make a system scale, you try and overload it, and then it all comes to a grinding halt, right? We've all seen this problem before. We know how it works. And building things to scale, you need to really think about that, right, from the start. Now, why is scalability so important today? Well, we live in a world where everything is always on, right? Internet access is relatively cheap. It's globally available. Everything from the rise of machines, people using mobile devices all the time, fast-growing middle classes in some of the most populous countries in the world, all basically points to one thing: people are always using any of your services all the time, right? You can't afford to have downtime. You can't predict spikes sometimes, and you need to be able to scale out on demand. So very important things in business today. A part of the driver for this, again, is also cloud, because cloud servers are very easy to provision and scale outwards. Well, most apps do that now, just because you can scale out and deal with additional load and all that. You have to do that, but it means that your application needs to deal with it as well. Just having the infrastructure isn't enough. Just having servers that scale out isn't enough. You need to build your app to make use of that. So before I go into more detail, again, a few thoughts on scalability in general. I just want to kind of step back. Are people familiar with the term horizontal and vertical scalability? Yeah? Okay. So essentially, I am talking about horizontal scalability here. Vertical scalability is essentially getting a bigger machine. That's what it means. If you need more processing power, if you need more capacity, you just buy a bigger machine. Now, that works to a point, until you get to a limit where you can't get a bigger machine. You've got the biggest machine on the planet already. What else can you do, right? Also, that's a very expensive approach. I mean, big machines are very expensive compared to cheap commodity hardware. And horizontal scalability is all about adding more cheap commodity hardware into a cluster and getting an aggregate amount of capacity or processing power, right? So we all know the terms, are familiar with that. I'm specifically talking about horizontal scalability in this talk. Now, one of the other aspects of horizontal scalability is the ability to scale back in as well. Scaling out is one thing. Getting more capacity is one thing. But what if you don't need it anymore? I mean, if you're dealing with an application that's very spiky, that's got lots of peaks and then troughs, you don't really want to have everything running all the time. You want to be able to scale back down again and save cost, right? So again, that's an important consideration. So what prevents us from scaling outwards usually? What's the real challenge here? Usually it is data storage, right? Scaling out for processing power is relatively easy. If you want to have more CPUs or more cores, just go on to EC2 and fire up, spin up some more nodes. Your load balancer will take care of it. You're fine. It's not that hard, right? The hard part is actually dealing with data storage, dealing with some form of persistence. Now, most useful apps store data, right? Who's got an app out there that does not store any data, that does not have any persistent data at all? Right? Nobody, right? So, I mean, anything useful you're doing is going to store data at some point, whether it's long-term persistent data in a database or something, whether it's transient session data, you're still storing stuff. You're still maintaining state, right? And that's the hard part. That's a difficult thing to scale, especially maintaining consistency and everything else. Now, the traditional way of storing data in applications have always been the database, right? The relational database. It's been around for a long time. We know how to use it. We're familiar with it. The problem with the relational database, though, is that it acts as a single point of failure, firstly, but it's also a very big bottleneck. You can't scale out a database very easily. Horizontal scalability in databases is very hard, mainly because of the relational model around it, around how you organize and structure your data. Now, some databases have attempted to do it, some have succeeded to some degree, but achieving true scalability with a database is very, very difficult, nigh on impossible. This is kind of where NoSQL comes in. A lot of the NoSQL engines you see, the NoSQL storage engines you see, have been built to try and solve that problem, to try and solve the problem of horizontal scalability. And the way they've achieved it, there have been various techniques around that. In some cases, you loosen up the structure of your data, right? You use things like documents or simple key value stores. So it's not as complex as a full relational database. Your data is more loose, if you will. It makes it easier to scale outwards. The other thing is consistency models, and this again helps you scale out, but it means that your data may be, the correct term is eventually consistent, but it means your application needs to be aware of that and needs to be able to deal with that. So again, makes things a bit more complicated. Data grids, again, another very good option when it comes to scalability. And the reason why data grids are actually interesting is because they work both as a NoSQL key value store, but also as something to sit in front of a database, as sit in front of a traditional database, or even a traditional, or not traditional, but a NoSQL store to act as a performance boost. So I'm going to talk a little bit about data grids here. What are they really? I kind of look at data grids as an evolution of a distributed cache, right? We're all familiar with caches. It's a useful pattern we all know about to try and remove bottlenecks, right? If you're doing an expensive operation or hitting an expensive database to retrieve data all the time, you can scale your reads by caching stuff in memory, right? Quite easy. Not that easy. You also need to think about whether that data is stale, when the data expires, you got to clean it up. What if your application is transactional? You need to be able to make sure that fits within your transactional scope. What about warm starts? If you want to preload a cache, again, more complexity, right? So not that simple. But the hardest part with a simple cache is that the moment you start distributing your application, like I said, scaling out is easy for processing power. Spin up a few more EC2 nodes, you're good to go. Stick that in your load balancer, you're good to go. But your caches need to be aware that you're running in a distributed manner. You need to be able to invalidate things that other servers are changing. If you don't do that, you're going to have a lot of inconsistency in your data, and that's bad for most cases, right? Right. So that's where distributed caches come in. Now, data grids are a step beyond distributed caches. They're a step beyond in the sense that it's not just a simple put and get and remove API. That's not all you do with a data grid. You can do other stuff as well. You can do other stuff like you can query a data grid. You can write filters. You can do things like MapReduce against your data, which is, again, very useful things when you're thinking about a distributed environment. Why is that? Because the most expensive thing in a distributed environment is the network, is making network calls to try and find your data and retrieve data from across the network, right? So it is cheaper sometimes to push your operations or your computation logic into the grid and just pull back a result. That often works really well. And this is one of the patterns that data grids tend to do. Now, one of the other things with data grids is they are distributed by nature, right? So they're distributed data grids, they're clustered by nature. So you get a few things for free, a few pretty cool things for free, like elasticity. You can actually scale out and back in. It's built that way. That's the way it's designed. You can you have fault tolerance, again, high availability, again for free. Because you have many nodes in a data grid, if some nodes were to fail, that's not a problem. You would not have lost any data. You can still continue running your application, and so on and so forth. Okay? How are we doing so far on boring theory of data grids? Yeah, okay. Everyone happy? So I'm now going to talk a little bit about standards as well before I continue on. A few hands went up when I mentioned these JSRs earlier. I think they're both very important JSRs. The first one now is scheduled to be in Java EE7, so JSR 107. It's about time we had a standardized caching API for Java. I mean, everyone's been using caching a lot, but there is no standard way of doing it, which is kind of crappy. And at last we've got a standard way of doing it, and hopefully that's going to make it into EE7. That's going to help with scalability a lot. 347 is a fairly new JSR. I'm the spec lead on 347. We're talking about trying to standardize data grid APIs, not just simple cache APIs. Here we're talking about things like standardizing the way you do MapReduce, the way you write queries against a grid, the way you would do operations, asynchronous operations with futures, eventual consistency, all of that. And this is all really useful again for, a lot of data grid vendors do this stuff anyway. They all implement it anyway. They just do it in a very non-standard and proprietary manner. Having a standard API is always a good thing for portability and everything else, right? Now, who here does not like standardization? Good. That little slide there, that's by the smart people at Gartner. They talk about how data grids are really important in the enterprise. Essentially, by 2014, at least 40% of large organizations will have deployed one or more in-memory data grids. The reason why, purely because of scalability, you need to be able to scale. Data grids are probably one of the best tools out there to help you do that. Okay. How are we doing so far? All good? So all that was the boring stuff, right? That's the introductory stuff about kind of setting the scenes, the lay of the land, if you will. I'm actually here to show you guys how we build a web app and how we then make this web app scale, right? What I am going to do, like I said, I've talked about how scalability and high availability is very important. I've talked about how data grids can help you achieve this. Talked a little bit about CDI, but now specifically I'm going to show you how using a data grid in CDI is very, very easy. It's a fairly contrived web app, unfortunately. Like I said, I'm not a web app developer usually. This is essentially a very trivial app that's going to read stock prices from typically a REST service or something, or a database, essentially an expensive data source, right? And this web app is going to render this in a web page using array. And you can then go type in a stock symbol. It's going to give you stock price, and it's going to update that periodically by pushing updates into your browser. And this is where I'm using array again to create that connection between browser and server without writing too much code. And you're going to wire it all together using CDI. All right? So let's switch to my IDE and my eye-wateringly painful color scheme. Can you guys see that? Is that all right? Does that make your eyes bleed? No? Okay. Essentially, what I'm doing is, So this is an application entry point. It is a GWT-based application, right? Array is GWT-based, as I said. Are people here familiar with GWT? Yeah? Okay, good. That's more than me, because I actually am not familiar with GWT. But anyway. I've created a page here with a label, a button, a text box, ... This is where I build the UI. I put it all together. And there you go. I've got a couple of horizontal panels. I'm adding the UI components there. And I've added an event here whenever I click a button to submit a stock symbol that I'm interested in. It ends up firing an event. Now this bit here, this is a little bit of CDI going on. I'll show you in a second. The first thing is I've got this stock type. It's a very simple bean here. It just basically is a wrapper around a string, right? A stock symbol. Nothing too complex going on here. The one interesting thing I do want to point out is I've annotated this as portable. That's a little bit of array going on there. What portable basically means is it's a bit like saying implements serializable or something like that. It basically means that that object can be marshaled. Now, the difference between just using serializable and using this array annotation at portable is that at portable means that that can be serialized both in Java and in JavaScript. And that bean is going to be automatically translated into JavaScript and going to run in your browser as well, right? So that the JavaScript that's running in your browser has access to this bean as well and is able to have all the rich functionality around that. So you can do some really cool stuff with array that way. Yeah, there you go. That's the import over there for at portable. So that's an array annotation. The next class over there, that's response. That's the response that I get back every time I submit something to the server. I'm going to get a quote, which is a price. I'm using a string here instead of a float just because I'm formatting it on the back end before I submit it to the browser. So this way I can do my number format and things like that. Right? Like I could pass in a float as well and do the formatting on the front end, but that just makes the code a bit more clunky. Again, very simple bean, nothing clever here. This is portable as well because this again is going to run in the browser as well. And I've marked it at conversational, which means that this lasts for the entire duration of a session. It's actually not an entire session, but until I change this symbol again, that bean is going to exist. Okay, where are we now? So we'll go back to the app over here. I've attached a handler here to the button that I've got. So every time I click the button on my web page, it's going to fire this event, fire message, and essentially I'm just taking the text that's been sent back. So this seems a bit like request response, something we're all familiar with, but it's not really. It's, you might say, an evolution of that. Every time I see a response from the back end, I'm going to basically update the label on my front end, on the browser. Now, this is a CDI annotation here at observes. It basically says that every time I get a new response from the back end, I'm going to update a label in my front end. The server can send many responses. It does not have to send one. It's not a request response sort of style, even though I've called it response. What it really is the server making a change to your session, to your conversation. And then your browser knows about the changes and can update stuff, right? That's pretty much it. The rest is just boilerplate over there. Which one? Observes? This basically is that that event is fired every time there's a change to the response type within that conversation. So every time another component makes a change to that response type, which is a part of your conversation, that method's going to fire. Now, the interesting thing here is, I mean, this is a standard CDI annotation. It runs within a CDI container. So two different components on the back end would communicate this way. But this particular case, this is interesting because we're actually looking at a GWT application here. This is actually JavaScript. This all gets compiled to JavaScript and runs in your browser. So your browser now is a part of that CDI conversation with the back end, which is what's really cool. And as far as the code is concerned, this just looks like bog standard CDI. It doesn't look anything more complex than that. Let me actually show you this as well. Oh, never mind. I was actually going to show you the various parts that are compiled to JavaScript, but anyway. Okay, so this is the actual application here. What you just saw was the JavaScript application, the GWT application that runs in your browser. This is the back-end component over here, the simple CDI service. I've called it simple CDI service. I've made this application scoped, which means that only one of these is going to exist for the entire lifespan of the application. I could make it conversation scoped if I want to store state about a particular conversation. I could make it session scoped. I could do a lot of things with it. But in this case, like I said, it's a fairly simple, contrived example, so this is just going to be application scoped. What I'm doing here is I'm injecting, I'm setting myself up with an event here. Now with this event, I can now make changes to it, and anyone observing that event is going to get notified of changes. So this is the @observes that you saw in the GWT application, right? So that's observing that event there. Now I've got a handle message method here, and that observes the stock symbol. Now this is the same thing happening the other direction. So whenever the GWT app changes the stock symbol, it notifies this backend saying this conversation is now interested in a different symbol. Go and do something else. So that method there fires. I've got a simple bit of logging over there, telling me what I'm looking for. Now, what I'm specifically going to do here, like I said, it's a fairly contrived example, but I want to be able to push prices to the browser of whatever symbol someone's interested in, and I also want to be able to update that periodically. In this case, my update frequency, I've set it to 1 second. That's 1,000 milliseconds over there. And I'm using an executor service here to schedule this at a fixed rate to fire a response to the browser every second with an updated price, right? So very simple way of having browser-server communication here. The actual method over here, yeah, so I'm calling this method getQuote to actually get an updated price for that given symbol, and I'm going to fire that event. So let's have a quick look at getQuote. I've not actually implemented this as a REST service. I could have. I didn't really want to trust the internet connection here. So instead, it's just going to generate a random number and push that up to the browser, right? Now use your imagination again. Imagine that's a very expensive method. It's doing a lot of hard work there. It's not really, it's just generating a random number, but you know, right? It could be a REST call, it could be a database call, whatever, right? And that is pretty much it. So let's have a quick look and see what this looks like. I'm going to build that. Yeah, it's kind of tiny, but essentially all it's doing is I'm just doing a Maven install and then I'm copying the WAR file into JBoss to deploy it. So that's really all I'm doing. And while that builds, let's hope that does not download the internet. We're good to go. Okay. Now this is my JBoss AS7 directory. I'm running 711 final here. I'm just going to start up my app server. Now, just like any other Java EE6 compliant web app server, all the CDI components that I need already exists in JBoss. So I don't need to have any extra jars. It's all, if I show you the POM file I'm using, it's all provided basically. I've marked everything as provided. So let's go down to my browser now. Let's actually zoom in on that a wee bit. That was a previous run. Okay, there you go. Whoops. GWT does not like zooming. Can you believe that? All right, let's try and get a quote on something, and there we go. Oh, whoops, what's going on there? Something's not been wired properly. There we go, right? So it is generating random data, like I said, pushing it out to the browser. And again, like I said, use your imagination. Imagine that's a very long, complex, expensive operation that's going on, right? So let's stop this for now. Let's head back there. So that's kind of what we've seen so far, basic web app, right? Very simple, kind of contrived, but you kind of get the idea, right? Right. So what have we actually achieved? I mean, does that app scale? Does anyone think that app will scale? Not really, right? I mean, those REST calls are slow. How do you deal with that? How do you want? You don't want to do that every time. Also, when it comes to clustering, how are you going to deal with that as well? The more servers you have, the more clients you have, you're just going to saturate and overload your REST server or a database or whatever, right? So very, very expensive, not very scalable. So what can we do about that? Now, we can try and cache the results of that lookup to that REST service, right? That's an easy way to do it. We can add some expiration around it to make sure whatever we cache does not live forever. We want to invalidate it after a certain period of time and then go and fetch a new copy from the service. We want to make sure it's cluster aware. So if we want to scale our app out and deploy it more app servers in front of a load balancer, we want to make sure if any one node was to invalidate that data, everyone knows it's invalidated, right? We want to keep things consistent and coherent. So we all know how to do this. This is all stuff that we've done before. But it involves quite a bit of code, right? It involves writing quite a lot of extra code. Trivial code, granted, but still a lot of stuff. And especially if your application is anything more complex than my trivial app here, you're actually doing a lot of things and you're caching a lot of things everywhere. And you're writing a lot of boilerplate code, which is a real pain sometimes. But it's not really, it doesn't have to be that way. And this is what I want to demonstrate now using CDI. The annotations I'm going to show you here are all a part of JSR 107. There's nothing proprietary, nothing specific to Infinispan. I'm going to use Infinispan in this particular case, but the annotations themselves are all standard annotations. Okay. So, how many lines of code do you think I'm going to need now to do everything from making this cluster aware, storing stuff in the cache the first time I look at it, and then retrieving it from the cache subsequently, adding expiration as well to make sure things. I've got a 1 second update frequency there, so I want to make sure nothing lives in that cache for more than a minute, right? How many lines of code do you think I'm going to need? How about 1? Actually, no, I'm not. Yeah, if you got the configuration, that's a bit more. But yeah, essentially, what I want to do is it is as simple as saying I'm going to that method that's going to get called get quote over there. I'm just going to annotate that with at cache result. That's it. Now that is like I said, a standard annotation. That is a a javax.cache annotation. Right? It's part of JSR 107. What that basically means is that the first time that method is called, it's actually going to get invoked. The contents are going to get invoked. Any subsequent time it's going to get called, we're actually going to look in the cache before invoking that method and see if that result already exists. The cache key that's going to be used by default is the parameter, in this case, the stock symbol. If I have more than one parameter, it'll be an aggregate of all those parameters. I can control which parameters are used as a key by adding the, again, let's just assume we've got more parameters here. Let's just say int. I've got a parameter that's going to be ignored. And I don't want that to be a part of my cache key. So in this case, I can say, okay, I just want that to be. So in this case, just that is going to be used as the key and not that. That's going to be ignored. So I get to control some of that as well. There are a few other bits and pieces to these annotations that I'm going to show you. Oops, I've left the... There we go. A few other bits and pieces. I can specify the name of the cache I want to use. So for example, if I've got several different caches in the system, if I want to store my stock symbols in one cache and some other data somewhere else, I get to control which actual cache is going to get used here. I get to specify a few other things like a key generator and things like that. If I have a more complex way of creating aggregate keys. Now in this case, I'm only going to use symbol as the key, so it's simple. If I have more than one parameter, it basically creates a list of the various components. But I also can provide my own key generator if I want to have my own complex mechanism of creating a key out of those parameters. So there's a lot of customization you can do there. Let's get rid of that. And it really is as simple as that. So let's call this, I don't know, right? That's your basic annotation. Sorry, question. I'm sorry? Right, now that I'm just going to show you that right now. The next step is how do we actually configure that cache? By default, it's going to create the default cache that your implementation is going to provide, which may or may not be what you want. Most implementations, their default cache is not clustered, it's not distributed, it does not have expiry, does not do very much. It's a very simple in-memory cache. I will now configure this using CDI as well. Sorry, one more question back there.
So the stock is a class. Do you need to provide some method on that the cache can use to come up with a key value?
Essentially, JSR 107 does not define anything more than does not put any constraints on your keys. You can use any object as a key. So yeah, in this case, that stock type is going to be used as a key.
Okay, that's an assumption that each symbol has its own stock.
Yes. Yeah, you will have to implement equals and hash code and things like that on stock to make it work properly, which I may not actually have done in this example. I'll have a look at that later. So yes, now how do we actually configure this? Again, there are two ways to configure your cache. One is provider dependent. It is proprietary to different JSR 107 implementations. Provide an XML file basically, or something along the lines, or programmatically do it. The other way is to use CDI again to actually build your configuration. CDI is actually very good at doing that as well. Now in this case, I've created a component, a CDI component, that holds my configuration for my stocks cache, right? I've got this method here called getConfiguration. Actually, before I look at that, let's have a look at, anyway, so I've got this method here to create a configuration. I've annotated it as a producer. So at producers, this is a CDI annotation which says every time anything in my CDI application asks for a configuration object, a cache configuration object, this is a method that's going to produce it, right? So it knows how to wire it, how to wire up your application. And I'm using that, I'm hijacking the wiring system to build my cache as well, right? So I'm marking this as at producers. This is an InfiniSpan specific annotation, which makes it easier to deal with multiple caches in a single system. So I know that this producer method only produces the stock symbols cache, not any other cache, because I can then have different caches in the entire system and can wire them up differently with different characteristics if I want. Again, this is, now the stuff you see in here, this is InfiniSpan specific, where I'm actually building a configuration builder. I'm setting some expiration. I'm setting a lifespan of all the data in there to have a lifespan of 1 millisecond again. That's it. Very simple, nothing too complex. And I build the configuration and pass it back. And again, CDI is able to, actually not CDI in this case, this is actually an InfiniSpan component as well, which registers itself with CDI if it's running in a CDI environment, that if anyone asks for a cache, it will look for a configuration like this, grab that configuration, build it for you, and give it to you. So now, at this point, if I go back to my application, whenever that method gets called, CDI knows what to do with that cache result, so it will then look for a cache within the application with that name, and it is able to get a hold of it and use it, basically. It's quite simple as that. It's nothing too complicated. Now, if I suddenly wanted to make this a clustered cache, I can just change stuff here in this configuration. I can add more characteristics to it. I can make it clustered. I can make it transactional. I can do a lot of other stuff with it. All right. How are we doing so far? Okay. Now, I've not really used too many. I've not really explored too much of CDI here, or the CDI JSR 107 annotations. I'm going to flip back here and show you some of the others as well. This is pretty much the tip of the iceberg. That's kind of what that picture is meant to show you. Some of the other annotations that we have, we got at cache result. We can also annotate methods with at cache put, at cache remove, all of this stuff. These are all, again, JSR 107 annotations, so they are they are standards, basically. I'm sure you can guess what they do. It basically means that you have more fine-grained control over what's actually happening in your cache, what's happening in your data grid, all via very simple CDI annotations of your application, right? So just flip back here. So any questions so far on this and how this is working? It's literally just one line of code there to.
On your configuration section where you said that you're using the InfiniSpan specific stuff,
Yeah.
is there not
JSR 107 does not define a standard way of configuring a cache, unfortunately. That's where there's a bit of a gap in 107. 107 leaves the configuration part of it to vendors, which kind of sucks, really, but yeah. Well, I did not use any XML. It was all programmatic, yeah. It was all here in that producer over there that produces a configuration bean for me.
So is it the app server then that the CDI container part?
It's your CDI container that wires it for you,
So
yeah.
the method is invoked like the first time or something,
Mm-hmm.
and it says, okay, I need to find a configuration in the same package?
Yes, absolutely. In the same application. It's in the same CDI application. I'm sorry? So just for, in case no one could hear that, the question was whether that ties the stock object from the back end and the front end. Essentially, you're kind of asking whether I'm caching stuff in the browser, right? No. The reason why I'm not doing that is, again, for this specific example, to demonstrate a lot of load on the back end. I want that to be there because it makes sense for this example. I could cache it in the front end too. You're perfectly right, but this is a fairly contrived example. So. The events? Yeah. I mean, so there is an event in my GWT application there. I'm sorry? Yes. Yes. Yes, that's it. If you have multiple methods, well, that'll be a CDI specific thing, which there are ways to specify what you want to observe and what you don't want to observe. I've just used a very basic example here.
How do you verify if a cache has been created?
I'm sorry, if a cache has
How
been?
do you verify that the cache, with that annotation,
Yeah.
verify that it's already used the cache?
So how do you verify it's already using it? Well, you can, you can see how fast it's moving, firstly. Things will actually move a lot faster because you're reading stuff from memory rather than going to an expensive data store. So you can add further logging to it. You can do a lot of stuff to it.
Your example is on J was 7.
Yeah.
In things and the whole thing is a recorded video. Is there any way to verify in J was 7 the cache is on this?
Okay. Well, you can add logging statements to it. Every time it's created, it registers with JMX as well, so you can use JConsole, something like that, and actually look at your InfiniSpan grid that's running in the same environment. You can use that to query what's in the grid as well. Yeah, you can do stuff with that.
Does the JSR state any kind of standards for miner?
No, unfortunately. So that again is vendor specific. The JSR is quite thin on things like that. It is just API, really. Yeah. No, it doesn't do that. But you could do something like let's assume. In this example, it's doing it lazily. So the first time you request for something, it's going to do the hard work and then store it in the grid afterwards. You could do something like create another method and annotate that with post create or something like that. So when your application starts up, you can do all the hard work at that time and populate your cache. Yeah, which is why doing something like preloading isn't always useful because you don't know what your application is going to need. So. Yes, absolutely. Absolutely. That is the benefit of doing something like this. So you have multiple sessions looking for the same symbol. You're not going to sit and have different, retrieve that data multiple times. Yes. Anything else? All right. More? Now, this is where things get a bit interesting, actually. I'm glad you asked that question. On a trivial level, to actually configure it to run in a cluster, I'm just going to change things here in that producer. What actually happens is, in this case, again, talking about InfiniSpan, the actual cache nodes start talking to each other, form a cluster. If you store anything on any node, it's available to any other node in the cluster as well. But more importantly, if any one node was to change something, or invalidate something, again, every other node is aware of that and you are consistent. So yes, it definitely is clusterable in that sense. And that's an important part of being able to scale out, a very important part of it. Yes, there are different ways of configuring InfiniSpan to do that. We can do a very simple replication mechanism where every piece of data is available everywhere. Very good for a very read-heavy environment where the actual volume of data is not that big. But that's not very good if you're doing a lot of updates as well, because every time you make a change, you need to tell everyone else in the cluster that you made a change. That gets expensive. So we have a different mechanism as well called distribution, which is a little bit more complicated than a simple replication model, where you pick certain nodes as backups and make sure there are enough copies in the grid, but not too many copies. And if there's a miss, you know where to find that data elsewhere in the grid and things like that. Mm-hmm.
I found that the most difficult parts tend to be if you've got different versions of the service requiring distribution of entities, and you've got two separate versions of an entity.
Of your entities themselves, yeah.
The problem of class parts and trying to isolate parts of some services in some cluster or big island, basically. Is that something which you try to attempt to address in the JSON?
No one's proposed it so far. But like I said, the JSR is young, and if you're interested in bringing that up, please do. I'll leave you with some URLs at the end where you can participate in the JSR. And yes, it's certainly an interesting case. People do talk about that with Infinispan and JBoss Data Grid as well. They use it in such environments. Our usual recommendation there is to provide a custom marshaller. You can plug in your own serialization framework, and that's kind of hacky, but it means then that you can plug into any modular system or OSGI or whatever, provide your own class definitions for serialization and deserialization. Some folks wire that up using Apache Avro or Google Protocol buffers, where you have version-aware marshalling, if you will. Yeah. But that's not a standard. It's very hacky. It's non-standard. Yeah, I don't see why that shouldn't be a part of the standard. Yeah, makes sense. Yes, you can. I know that Greg Luck's got some demos using cache as well, and Terracotta. I think you can. I think I've seen a couple of coherence demos as well doing the same thing. So, like I said, the annotations are standard. The only non-standard bits are that little bit there, how I'm configuring the cache. So that could be anything really. Sorry. I'm sorry.
I said, yeah, the annotations are standard. There's a lot going on.
Well, those are just implementations after that. Because the annotations are a part of JSR 107 and a part of CDI, if you want to call yourself 107 compliant and CDI compliant, you have to implement them in the same way. What actually happens may be different, but it'll have the same effect. That's an interesting thing. I might rewind a little bit to NoSQL or NoSQL in general, because they have the same problem as well. A lot of NoSQL databases deal with that. Are you familiar with Eric Brewer's Cap Theorem? A few nods. Unfortunately, I shouldn't really be talking about that here, because that'll be another hour. Maybe I'll have a chat with you afterwards about it. It is a very complex issue that the industry standard of dealing with it is eventual consistency, where you weaken consistency for the sake of performance and dealing with split brains and not shutting down in that case. But that makes things complicated for the application developer, because you suddenly might have two versions of a given entry. How do you deal with that? Right? In Finispan specifically, by default, we are strongly consistent. We are not eventually consistent, which basically means that we don't deal with split brains. If you see one, we shut down, or we go into read-only mode. And at that point, it's up to the system admin to clean up. Although we are working on an eventual consistent model as well, where you get to choose between the two in your configuration, whether you want to be highly available or not in that case. Anything else? Okay, so, damn it, now that happened. This screensaver came back on. Okay, going back to these, I also want to talk a little bit about what we're going to do next. I mean, this is all the stuff we've seen in JSR 107, which is quite useful, as we've seen. Right? It makes it very easy to help your application scale. What are we doing in future with JSR 347? Now, I'm not going to talk so much about the API part of it. There is a lot we're going to do there as well, like standardizing MapReduce and querying and things like that. But in terms of CDI, I actually want to be able to wire this up again as well, to be able to say, have producer methods and have a query in that annotation of a producer method to say, this is how you're going to actually find this data and create it, which would be quite cool. Things like being able to do MapReduce and remote code execution, again, via CDI, to be able to annotate, for example, methods as mappers and reducers in your CDI application, just to kind of make that a little bit more fluid, a little bit more, you're using one programming model for everything. Now, these are just a few ideas. None of this is carved in stone, like I said. 347 is quite young. So I'd love to hear your feedback on that, especially on the mailing lists. As users, what would you guys find useful? What would you guys find interesting? Yeah? So to kind of sum things up, basically we talked about why scalability is important. We looked at building a web app using CDI and Arai. We showed how we added data grid, just a few quick and easy annotations to boost performance, all via CDI. We talked a lot about JSR 107 and 347. So with that, I'm sorry? Oh, yeah, absolutely. That's a good point. We talked about it. Actually run it. Okay, where are we? Yeah, we've got that. I'm sorry. Stocks, cash, and what have I called it there? Oh, you are right. Well spotted. There you go. Okay. Yep. Let's rebuild that and push that out again. Yeah. That one there?
Yeah.
This.
I didn't really catch what that is.
Yeah, I mean, I didn't really need to do that. I just did that. I actually don't know why. That's useful if you actually want to inject the cache into another part of your CDI application and use the cache directly, use the cache APIs directly. I'm not actually doing that in this application, so I shouldn't have bothered with this, but yeah, that's actually distraction code. I should get rid of that. There we go. I'll get rid of that.
You know, you could stick a log statement in there too to prove that it's not getting printed.
Have I got one? No, I don't. You're right. Well, let's just fire that up first and. There we go. Oops, what's going on there? Something's broken there. That happened the last time as well. I guess those updates are a bit slower. One thing we could do to demonstrate that a bit better is maybe change my expiration characteristics configuration to have things expire, I don't know, every 10 seconds instead of every second, so that things won't update as frequently. Go. Now it's doing that weird thing again. I've got to restart the app server. I have no idea what's going on there. I'm not a web app developer, like I said. It's like, app servers, what are they? I mean, you know. Right. I have no idea what's going on with the app server there. Fine, I'm giving up on that. But yes, so like I said, I'll leave you guys with a bunch of URLs over there. You can find out more about this stuff. Specifically, I think the 2JSR URLs there are interesting. Quick note about 347. Who here participates in the JCP? Is anyone doing anything with any other JSR? No? Okay. Well, a quick note about the way JSRs work. I mean, traditionally, at least, it's been quite a few hoops to jump through to get involved. You've got to become a part of the JCP, get approved by the existing expert group and things like that. That's exactly not how I'm running 347. I'm an open source guy. I'm used to working in an open source community. I am running 347 as a community effort. So the mailing lists, everything else, it's all in the open. You don't need to be a part of the JCP. Anyone's allowed to express their ideas. I don't want this to be a vendor-driven JSR. I'm tired of vendor-driven JSRs. I want this to be a community-driven one. I want people to actually tell me what they want, as opposed to vendors saying what they want to build. Right. So yeah. With that, well, if there are any other questions? No? More there?
So GSR 1.7 started for Java 7?
Yes. Yes.
Do you know of anybody that's got it using already, or something very similar to it? I mean, obviously it's not standard yet.
So InfiniSpan is very close to 107. The reason why we've just not finished it is because 107 is not in final mode yet. EH cache again is very close. A lot of them are very similar. So yeah, I expect it to be out very soon. It's in legal hell at the moment between IP lawyers, but that will get out very, very quickly now, hopefully.
The same question about 3.7, obviously. Are you targeting trying to get it done by 9?
8 is my target, but yeah, I mean, it should be ready long before that. So I don't know if you're familiar with the Adopt a JSR program. So Java user groups around the world can adopt JSRs, and the Houston Java user group have adopted 347. What that means is they're building and contributing a reference implementation and the TCK for it. So again, it is a very much community-driven effort, and that means that you're going to see an RI and a TCK out quite soon, because actually people committed to it, which is great.
More caching? You can have a global cache.
Yeah, absolutely. Yeah. Yeah. Okay, well, with that, thanks for listening, guys. Enjoy the rest of the conference.